Day 14 of 365, and today we stop memorizing and start recognizing. Here's the problem most learners hit. You know what arrays are, but the second a question looks like it needs nested loops, you panic and write O and squared. Today we kill that reflex. By the end, you'll spot the two-pointer and sliding window patterns on site, and you'll know exactly which one to reach for. These two patterns alone unlock a huge slice of array interview questions, so let's drill them until they're instinct. Cold red. Container with most water, leak code 11. You're given heights like 1, 8, 6, 2, 5, 4, 8, 3, 7. Pick two walls. The water they hold is width times the shorter wall. The naive answer feels obviously correct. Two nested loops, check every pair, track the max. And it works. But run it on 10,000 elements, and you're doing 50 million comparisons. Your interviewer already knows it's quadratic, and they're waiting for the better idea. Here's the insight. Put one pointer at the left wall, one at the right. That's the widest possible container. The area is limited by the shorter wall. Now ask the magic question. Does moving a pointer inward ever help? If I move the taller wall, width shrinks and height is still capped by the short one, so I can only do worse. But if I move the shorter wall, I might find something taller. So we always move the shorter wall inward. Each step eliminates a column safely. One pass, O of n. In Python that's left equals 0, right equals length minus 1, best equals 0. While left is less than right, compute area as min of height left and height right, times right minus left. Update best. Then if height left is less than height right, left plus plus, else right minus minus. That's the whole thing. Boundary check. Empty or single element array can't form a container, so guard for length less than 2 and return 0. 50 million operations became 10,000. Now watch the problem shape change. New question. Max sum of k consecutive elements. This is not converging endpoints. The window is a fixed size that slides across the array. This is the sliding window pattern. Brute force recomputes each window from scratch, O of n times k. Instead, sum the first k elements once. Then slide. Add the new element on the right. Subtract the one falling off the left. The sum updates in constant time per step. One pass, O of n again. But the mechanics are completely different from two pointers. In Go, window sum starts as the sum of the first k, best equals window sum. Then for I from k to n minus 1, window sum plus equals nums of I, minus nums of I minus k, and best equals max of best and window sum. That subtract the tail, add the head move is the entire trick. This exact pattern shows up in production. Rate limiting, network throughput over a time bucket, rolling averages on a metrics dashboard. K is just your time window. And there's a cousin, the variable size sliding window. Minimum size subarray sum, leak code 209. Expand the right edge adding to a running sum until the sum hits the target. Then shrink from the left as long as it still qualifies, recording the smallest length. Same window idea, but the size breathes instead of staying fixed. That one structural difference, fixed versus variable width, changes the whole loop, so always read whether the window size is given to you or something you're solving for. Decision flowchart to lock it in. Sorted array or two ends converging on a pair. Two pointers. Contiguous subarray with a running aggregate, sum, average, count. Sliding window. Unsorted and hunting for pairs. Sort first or reach for a hash map. That's the whole instinct. Day 14 done. The skill isn't the code. It's asking, does moving this pointer ever hurt me? And reading the window's shape. Subscribe for day 15.